Welcome to this week 7 tutorial. This is going to be an example similar to number 3, and it does not involve a lot of calculation, so I'm basically going to be just putting some words to the solution that's presented in the view and example solution. So from a survey of co-workers, you find 47% of 300 have already received the year's flu vaccination or vaccine. An approximate 98 confidence interval is 0.403 to 0.537. Now, if you recall, in part A, we're gonna want to find how would the confidence interval change if the sample size had been 1200 instead of 300. And this formula here is what calculates confidence interval. And how do you end up with two different numbers? You will remember that the plus or minus here is what gives you that. So this p hat is what the estimate is. Then to get the upper limit, you're going to add, and to get the lower limit, you're going to subtract this here, which is also referred to as a standard error. Now the z is the critical value, and p hat and q hat are dependent on the estimate, so the 47% will help to give you that, and the explanation is here for how you get how p and q are related. Now if we were to increase the sample size to 1200 instead of 400, that ratio is 1200 to 300 would mean that it goes up by a factor of 4. And looking at the equation to see how n, which is the sample size, comes to affect the outcome, if we stick 4n in this expression, which is what we have here for the margin of error, and if we change n to 4n, how will that impact the outcome? 4n underneath the square root sign, if you take out the 4 by finding the square root of it, it becomes 2. So it means that this original quantity here, when you change n to 4n, the result becomes a half of the original quantity, which means that the new margin of error is the original margin of error divided by 2. Because by changing n to 4n, which is what we did when we went up to 1200 from 300, then we noticed that the factor here has to be multiplied by a half to give us the new confidence interval. So the amount that you're going to add or subtract to get the upper and lower limit is going to be half the size. So it means you are going to end up with a confidence interval that's not as wide. So let's just look at that mathematically. If this is our estimate, and then our confidence interval is going to be, you're going to add the margin of error on this side, so that's plus your margin of error, and then on this side you are going to subtract your margin of error, so that your confidence interval is going to be this whole range here. Now we found out that if we were to switch as we did right here by changing the value of n, we are going to end up with a margin of error that is half the size. Now looking back at what it means here, all that it means, instead of all the way out to here, your margin of error is going to only add that amount and that amount. So it's going to translate directly to having a confidence interval that is half the size of the original. Alright, so that's what part A is really all about. Part B, how would the confidence interval change if the confidence level had been changed from 95 instead of had been used as 95 instead of 98. Now, if you recall that the expression for confidence interval is here and it has a factor called z in it, which is the critical value. And I'll just show you real quick what that critical value represents. The critical value, you can determine it using an Excel function called norms inverse. So for a 90% confidence level, it's going to be 0.9, which means the area that's going to be outside of the graph is going to be 0.1%. And let's just look back at that, because this foundation is going to be critical to you understanding it. If this is a bell-shaped curve and we are trying to establish confidence interval for 90%, it means we are trying to capture the range that shows 90% of the data. So 90% of the data will be within the range shown. So the 90% is there, which means that in these two tails we are going to have 10%. If we have 90% inside this range here, then 10% is outside. So on each side is going to be a half of 10. So we're going to have 5% here. So that's going to be important to understand, because what we are trying to find is the z value, the critical value here that shows when you have to cut off to capture only 90%. So just to recap, in this zone here we want to capture 90%, which means we want to exclude a total of 10%, but we're going to do it in a balanced way. So we're going to split this 10 in two and leave 5% on the tail to the left and 5% on the tail to the right. The z value attempts to give you a value for this critical point at which you cut off to leave 90% here. So that's a little background so that this calculation in Excel makes sense. So 90% is 0.9. It means what we have to cut off is 0.1. What you're going to share on each side is 0.5. So therefore 1 minus that 0.5 is 0.95, and that's what you're going to translate using the norms inverse function to come up with the corresponding z value. And these are also, there's a list that's shown on page 275, and it doesn't say how it's found. You can find it from a table, but you can also find it from the Excel function norms inverse. So these are the critical values for various different confidence intervals. Alright, so that's going to be important. So what you need to observe is, and let's stick this right here where we can still drag it over. If we change our confidence level from 95 to 98%, what will that do for the value of z? And let's do 98% real quick right here. This becomes 0.98 and it automatically calculates. So if we're going from 95 to 98, we're going from a critical value of 1.9 to a critical value of 2.3. So if you look back in this expression, you're increasing your critical value to 2.3 from 1.96. So therefore the confidence range is going to also increase. And in part 3 they want to know if we go up to 99%, which is going to give us a critical value of 2.57, and again the critical value is going to be larger, so it's going to make the interval larger. So that's essentially what this question is all about. It's building on a lot of principles in terms of understanding what this expression is, and if you were to change factors in this expression, what happens. So just to recap, if you increase n here, since n is in the denominator, this number, which we divide by a larger number, is going to become smaller. Overall, this is going to become smaller. So when you find the square root, it's going to be a smaller number. So if you increase n, you're decreasing this, and therefore decreasing your confidence interval. And if you think about it, if you increase the number of samples, then you are more likely to get a more accurate result. So that's not surprising. If you attempt to increase your confidence level, then to do that, you're not going to be able to be more precise. So you're going to have to give a wider range of values if you want to say, hey, I'm 99% sure that the true value lies in this range. That range will have to be stipulated to be wider than if you were to say 99% confidence. You're going to have to stipulate a wider range to be sure. Alright, so please reach out to us if you have any questions, and thank you for watching.